All right, we're going to write magnesium hydroxide, which is MgOH in parentheses, because hydroxide is a polyatomic, right? Remember when we were learning these, I said, don't pop the bubble. Leave those guys in the bubble. You're going to put the 2 on the outside, cross the charges across, right? That's where these are all coming from. Plus, we're going to have phosphorus acid, which is H3PO. No, that's phosphoric acid. So we're just going to move with it because I already wrote it, and you guys probably did too. So this is phosphoric acid, my bad. Okay. Yields, and then we're going to have magnesium phosphate, so Mg3PO4 with a little 2 on the outside, plus water. This is a typical neutralization reaction. Okay?
Typical?
Yeah.
So we're going to be seeing this a lot?
Towards the end of the year, yeah, for sure. You'll be fine. But I'm going to show you how this is actually, so what we're not going to do is draw 4 oxygens. Yay! You don't have to worry about doing that, okay? I'm going to show you how you're going to do it so that it's less. All right. So I'm going to go ahead and put my squiggly because I know that's happening. All right. Let's draw these boxes, okay? So this first one, we have magnesium hydroxide. So there's, how many magnesiums are in this little compound right here? What? 1. There's only 1 magnesium. There's no little subscript. You guys see that? All right, so this is just an Mg. This is why I'm showing you. Okay, this little 2 only applies to whoever is right in front of it, which is everything in the parentheses. So this is saying I have 2 hydroxides. So I'm going to go ahead and write OH, OH.
You want to put the box?
And then you're going to put the box. Were you excited? You didn't want the box?
No, I was just confused on why we didn't put the box around an empty it.
Oh, got it. Okay, so that's our first compound, okay? So this one you're like, that really didn't save us any time. You're right, but it's going to make it a little bit prettier on the other side. All right, so right here we have H3PO4 with no little subscript. So that means we have how many hydrogens? 3. So we're going to go H, and then PO4. How many phosphate ions are there? Phosphate. 1, just 1, because there's no subscript right here, right? So that just means we're going to put PO4, put it in its little bubble, and then put it in its little box. So we are not spreading that polyatomic ion out because we have phosphate on both sides. There's no reason to make our brains go crazy. Oxygens get messy, okay? All right. Now we're going to look at the product side. We're going to draw our box. So how many magnesiums are in magnesium phosphate? 3. So we're going to go magnesium, magnesium, magnesium. Okay. How many phosphates are in magnesium phosphate? 2. So we're going to draw PO4 twice. Throw it into a box. All right. Before you put H2O into a box, okay, what I'm going to strongly recommend you start getting used to, cross this guy out, put H and then OH above it. H and then OH. You have hydrogen hydroxide. What that just did for you was now you're balancing hydrogens and you're balancing hydroxides. It keeps it separate. It actually makes it so much easier. A lot of people don't do this trick and they are going in loops and loops and loops, okay? Hydrogen hydroxide is the way to go with waters, and you'll see that on your assignment today. All right, so now we're going to draw that into our box. Hydrogen hydroxide, put it in the box. You're good, okay? Sorry, I went over my line. Huh? Yeah, but it'll start cutting off.
What is that saying? Oh, hydrogen parentheses OH.
Yes, sorry. All right, so now let's balance this real quick. I said real quick. It's okay. All right, we're going to start just like we did the other ones though, right? So what you're hopefully seeing is that you're just balancing things. You're not worrying about trying to make the oxygens all match up and have that perfect coefficient and things like that, okay? What we're doing Start from left to right. All right, so we have magnesium. We have 1 over here. How many do I have on this side? 3. So I'm going to fix that. I'm going to go ahead and say, okay, I need 3 magnesiums, which means I need to make sure I have 3 of these boxes in order to make that happen, right? Okay, so treat the polyatomic like itself. So, okay, cool. So I have 3 magnesiums, 3 magnesiums, sweet. Now we're gonna look at the hydroxides. So I have 1, 2, 3, 4, 5, 6. Where's my hydroxide on my product side? It's in the water thing. Do you guys see that? HOH. We gotta have 6 of them. All right. That means you're gonna have 6 boxes on that side. Yee. So let's go ahead and get those written. H. I'm gonna stop doing parentheses for a second just to speed this up just a tiny bit. So 1, 2, 3, 4, 5, and 6. Okay. Again, I am leaving those things separate. Not writing H2O. I'm writing HOH. That helps me count up 1, 2, 3, 4, 5, 6 OHs and 6 OHs right here. Okay. I know, this is the only one that's super ugly, I promise. All right. Cool. So you're like, sweet, that was terrible. So we have 3 magnesiums, 6 OHs, 6 OHs. 3 H's. Looking over here, I have 1, 2, 3, 4, 5, 6. 6 H's. How can I fix that? I go to the lower number and I add another box of it. And then PO4. So now I have my 6 H's. I have 2 phosphates. 2 phosphates. We are done. And that's it. So, big point of this. Put your polyatomic ions into parentheses and balance them that way. Leave them in their box. You'll see on question number 2